All right, we're on the golfer practice one. This one's a little tricky, so make sure you look back to that example with the place kicker because it's very similar to that because we don't know time and we don't know initial velocity. So the first step is you need to solve for time in the x direction. Use that time by subbing it into the y direction, equation number 2, and then using solver to find v0. Once you know v0, it's back to business as usual. We can use that v0, we can plug it back into what we had solved for t here, plug our v0 in it and solve for that t. Once we know the initial velocity, we can go ahead and use equation number 3 in the y direction to find the max height. And we could then use that initial velocity also along with the time we found in part B to find the final velocity in the y. The final velocity in the x is going to be the same as the initial velocity in the x, which we'll have to use initial velocity for, and do magnitude and direction by combining those two components. Or tricky tiger trail, because it's a y naught equals y problem, you might remember, well, that means the final velocity is the opposite of the initial velocity. Now, it works a little different here with angled launch. The difference is with this negative sign, instead of above the axis at that angle, it hits below the axis at that angle. So that's our tricky tiger trail. So it'll have the same magnitude. The angle just goes from above the axis to below the axis when it lands. There's your hint.